Hey, what's going on, everybody? Dirk here. Welcome to the dungeon. How's everybody going? Apologize if I sound a bit groggy, a bit tired. I wanted to make a quick video before I go upstairs. Unfortunately, I can't really hang out here and chat with anybody. It's already late, and yeah, it's gonna be a long week at the job academy for me. So, yeah. Just wanted to make a quick video for Superbrain AK and also for Roland. Yeah, I can't remember his damn name because it's Japanese or something for flyback. Sorry, Roland. Yeah, but Superbrain was well, we've been chatting kind of back and forth the last couple of days about flybacks and things like that, and Roland was also wanting to know a little bit more about putting these together and how to go about insulating them. I got my, I got an array of examples here. These are all the flybacks that I've made. These two are failed ones, unfortunately. And then I have this one. I have 1, 2, 3, 4, 5 so far. They're all AC. I can rectify them if I want to. And then this is a finished one right here. This is a store, or bought on eBay, but it's an AC flyback. I think it's pretty damn cool. Yeah, got a little LED light in there. I can't push it too hard, but it still gives pretty good output. This one gives about the same output as this one, maybe a little bit more, but between 10 and 12 kV when I run it up about 55, 56 volts on the input power. But the way I go about, or the way I do this, things can vary. Like this one, for example, it's ugly as hell. It's probably the first one, was my successful one. Just stuck a bunch of pieces of ferrite together, wound it on there, and I just epoxied the shit out of it. As you can see, yeah, it's all epoxy, but it works. It's a low voltage, high current one, pretty nice. They're pretty much all lower voltage, high current style flybacks. This one gives out the most only because these are linked up in series. As you can see, there's a center tap right here. And yeah, these other ones here I had insulated with Teflon tape on the inside and the outside. It is held together with electrical tape, and there's probably bits of electrical tape also in there. This was 2 secondaries in series. Here's your series connection right here. A little piece of high voltage wire there. It's a smaller one, but still pretty badass. He's a badass little guy. Medium one. That's a standard, flyback core from your DC flybacks. Yeah, the bobbin on here unfortunately failed. I just had that as a reference, just to show you. Some really fine wire on there. And I did have this under oil, but the problem is I didn't have a vacuum pump. Because if you do this on a bobbin, you want to stick it underneath the oil, and you want to vacuum it. You want all that air out of all those windings. Otherwise, you're going to get a flashover. And it was giving out some really good output, but then I went a little crazy and yeah, went up in flames. That one was insulated a bit differently, but you can see where it kind of arced over there. Unfortunately, wasn't enough tape. It was a little bit poorly made, so I'm going to take that off, reuse the ferrite, and build a whole new transformer out of that one. It was also underneath the oil, but once again, if you don't get all the air out of this, the oil is only going to do so much. Like this one, I do want to vacuum pump this one. I mean, it is insulated, but these AC flybacks, they can only handle so much before they flash over. Yeah. And then you got this one here. I think I might have shown it or not. It's basically the same as this. It's a smaller secondary core. These ones are larger, obviously. And that was used wire from a bell transformer to ring bells. It's pretty good. Not bad. It's not the thinnest, but it's pretty thin. Pretty nice. And basically, this is the stuff you guys want. This is the Teflon tape. This is old. It was down here, but I'm just using it as a reference. It's a Teflon tape, or and they refer to it as plumber's tape, and this is the tape that plumbers would generally use to put on pipe, the threaded pipe fittings to make them watertight. But it's Teflon tape, and one layer of this is equal to about 1 kV of insulation. This is great. This is really good stuff to work with. It's fairly cheap. I get a roll for about €1. That isn't shit. So, yeah. Do about 3 or 4 layers per winding, and you're good to go. I mean, I can chuck the maximum amount of voltage of the power supply over here can give me, and everything's fine. The cores get a little bit warm after a little bit. These get a bit warm after a little bit. Now there is a bit of a high internal resistance. I haven't measured it yet, but the other thing I wanted to do was hook these pieces up together, but not using a metal bolt. I wanted to use a ferrite rod if I can find one that's thin enough to fit in between here, and then I can literally link these two together. I don't know if that's going to have a great impact or not. I have to talk to Sparky about that, because he would know a hell of a lot more about that than I would. That's generally what I do, how I go about doing it. If I want to make the bobbins, as you can see here, these are the tops. That's the top and the bottom. And you can make yourself a secondary, or you can just use it as is, and you can stick a couple of them on there, link them up in series, and if you have some high voltage diodes, you can stick some high voltage diodes in series with the with your secondaries, and make yourself your own DC flyback, pretty much just like one you would buy like this. That's basically the same concept. You can even stick a high voltage capacitor on the end there. You can have a DC flyback that you would find in a monitor. Of course, you would want to stick that under oil. If you were going to put the capacitors and diodes on there, because of the overvoltage, and then all bad things will happen, and you will be very unhappy. But yeah, that's generally it. I don't want to make this video too long, because it takes forever to load. So I'm going to give you a quick demo here. Because of no bullshit. Just using Teflon tape and a bit of electrical tape on the outside just to keep everything together. These are almost finished. I need to put high voltage leads on them still, make a nice stand for them and all that good shit. But yeah, give you a quick demo. It does get very hot, so wear out protection, guys. Turn the lights off for you. Ooh, it's a bit dark. I can't see. I'm gonna turn it on really quick. I don't have a power switch for this supply, so I gotta put it in and take it out. And the cores aren't glued together. Center tap. So, this is a quick demo just to show you. That's a key to making these things, or basically any high voltage transformers, to to properly insulate them. Otherwise, it's going to go up in smoke, and you're going to be really unhappy afterwards. Learn from my mistakes. I had one previously before too that failed. That's 3 failures. Until I got to this point. So hopefully this kind of helps you out in doing that. Also, one more way to do it before I go here, as far as insulating, is you can also use not this necessarily. You could use this, but it's a bit thick. If you get some thinner, like construction paper, or even the paper grocery bags, and 1 or 2 layers of those in between the windings, then underneath the oil and vacuuming it will give you about 15 kV, I believe, between the layers. I learned that from another YouTuber called Glasslinger. I'm going to check him out. He does like a full video on building a really kick-ass DC, high voltage DC power supply. It's very cool. So check that out. Anyway, video's long enough. Hope this helped anybody out. If you got any more questions, ask. I guess I don't know everything. If you're not sure, you can ask, or you can ask Sparky from Sparky Projects, or even Ant from High 1 Voltage 1 Rules. He knows some stuff too, obviously. You know, he's a fucking flyback nut like me. So anyway, take it easy, guys. Play safe. Cheers.